Hi everyone, and welcome to today's workshop. It's Ingest and Analyze IoT Data with Azure Synapse workshop. Today, as you know, most of IoT value comes from analyzing its data. However, ingesting and analyzing a high volume of data can be a complex task during this. During this workshop, you'll learn how to use Azure Synapse Analytics, a limitless analytics service to process and make IoT data available, IoT data to developers, and data analytics. Our speaker for today is Christopher Maneu. He's the Senior Cloud Advocate. He's a member of the startup squad. He acts as an advisor and technical liaison between startup developer communities and the product team at Microsoft. As the lead of IoT Advocate of EMEA Region, he's focusing on IT startups and teams, helping them graduating from prototypes to large-scale deployments, and ensuring Azure has the best experience for them. Christopher, I'll hand this over to you now.
Thanks, Firas. Hi, everybody. Good day, good evening, good morning. So today we will do a workshop about ingesting and analyzing IoT data with a new service that just came out in general availability in production grade Azure Synapse Analytics. You can follow me on Twitter if you want, and I will give you more ways to follow me and ask questions after the session. So what we will do today together, we will build an IoT infrastructure to get started. This is not the focus of this session, but we'll do a few things like creating a gateway with IoT Hub and creating a simulation for IoT devices so we can get actual live data coming into our system. Then we will create a data lake. Data lake is basically a way to store an infinite amount of data to store all this incoming data from these IoT simulators. And then we will try two ways to use that data. First one is to query the raw data directly with Synapse without any pre-processing. And the second one is if you need to analyze this data on a regular basis, like every day or a few times a day, we will see how to create a continuous job to integrate this IoT data into a structured database so you can query them more efficiently. If you want to follow me along during this workshop, you will need an Azure subscription already activated. If not, don't worry, I will give you everything so you can follow this workshop after the delivery. So you just can sit back and relax and watch me going through the workshop, and you can have plenty of time and all the instructions to follow this workshop after this event. So the first thing to do is we need to set up a bit of things within our subscriptions. So if you want to follow along right now, go on aka.ms/IoT-synapse-workshop. I've just sent the link on the Q&A section. You will find on the right side of your screen. And you can also bookmark this link because you will get access to all my slides and also all the content of this workshop after the event. So as I said, you can sit back and relax or do the things with me. And along the way, if you have any question live during this event, please use the Q&A section on the right of your screen. And if not, if you're watching a recording or doing this on your own after the event, you can go over to GitHub on the discussion pane. And then you can ask a question here, and I will be monitoring this place to answer your question after the event. So let's get started with a bit of work to set up everything we need to actually do this workshop, the IoT, the simulation devices, etc. It takes about 20 minutes of time. So let's get started. Let's use a script to set up, scaffold everything we need, and then we can spend a bit of time explaining what we are actually doing. So to do so, go on the GitHub repository and on the content here, click on set up your environment. And I have created a script that will allow you to basically create all the resources without having to do anything. So just copy this link And then we will need to execute this in a bash environment with the Azure CLI, the Azure command line installed. Maybe it's not something you have on your current machine, but that's okay. You can go over on shell.azure.com to use the Azure Cloud Shell, which is the hosted bash, available for free within your Azure subscription. And it's come already pre-configured with a bunch of different tools, including the Azure CLI, and also all your credentials. So you don't have to log in or do anything like that. So I've just copied this line of code and I paste it. If you're interested into what is inside this deploy script, it's already in the GitHub repo. So you can have a look at what I'm actually doing in there. So when you execute it, the script will ask you for two things. The first one is to set up a resource group name. So we will actually create all the different resources into one resource group, which is a way to, like a folder to regroup resources within Azure. So let's say RG Synapse Workshop AM, and then a unique prefix. A unique prefix is required because some resources we will create on Azure need to have a unique name across all the Azure customers. So what I'm asking here is 3 to 5 characters that basically be prepended to all the resources names I will be creating for you, and that creates a unique names. So for example, for me, I will choose C like Christopher, M like Maneu, S like Synapse, W like Workshop 1, and then you can tap Enter to launch the script execution. And we will see in a few minutes how it's doing and what the script has created for you. So let's back to the slide for a minute. So we just done this. It's okay. So what we'll see in this small presentation before going into the workshop itself, first, why we need big data solution for analyzing IoT data, and then how you can analyze IoT data with Synapse. You have different choices, and I will explain what kind of choices you have, and then we will see in real life how to do it. So first, why we need a big data solution for IoT. As said Ferras in his introduction, most of the IoT value comes from analyzing the data produced by IoT devices. However, IoT data is quite complicated. Most of the time, we get semi-structured data, for example, JSON documents, but we can also get binary documents we need to decode. So it's a lot of work. It's not a nicely organized data, and maybe you have different type of IoT devices that send the same type of information, like a temperature, but all these different markers models send the temperature data in different way. So you need to actually parse differently depending on the devices. Then we have the metadata of the IoT data. Most of the time, when an IoT data sends out an information, it just sends out the information. It doesn't send out any data about what device is, what mark and model, where this device is installed. And you may need to actually correlate data stored in another system, like SAP or an asset database, with the IoT data coming from the IoT object itself to be able to use that data. And from this metadata, you can derive other data as well. For example, if you know the location of the device and the timestamp, you can probably get a database to know the weather around this IoT data as well. And last but not least, we have more and more advanced IoT devices, and a lot of devices are sending raw information like images or video feeds that need a specific way to be processed to get interesting information, or at least information you can add into a database. So IoT data is complex and it's very non-uniform. And then we will try to introduce big data by using 3 terms we use for defining big data. The first one is volume. which is the amount of stored data to be analyzed. And the fact is, IoT generates a high volume of data. And even so, even if you have an IoT devices but very few data, most of the time you need to store this data for a very extended period of time. For example, if you're monitoring an elevator, you'll probably need to have all the historical data of this elevator to be able to create a machine learning model to prevent incidents or to do predictive maintenance. So even if an IoT device just sends one message per hour, maybe you will need to store 5-10 years of data to actually be able to extract any value out of it. Then we have the variety. As we just saw, and as opposed to relational data, IoT generates a very unstructured data, and it's difficult to get them in the hands of data analysts, for example, because they need or they are used to very structured and very organized data within your organization. And last, velocity, which is the frequency to which the data is generated. IoT can generate data very, very fast. Some IoT system generates 100 megabytes of data per second. Some IoT devices just send one message, like a temperature or humidity, every hour. So it's depending on what kind of IoT devices you're deploying, but you can go up to 100,000, even millions of events per second. So most of the time, when we want to get value out of IoT data, we need to use big data solutions. But it could be complicated to start with. On the left side, we have the Azure IoT Hub, which is an IoT gateway. If you don't know it, this service allows you to manage the device connectivity. So basically, all your IoT devices are connecting to the Azure IoT Hub, but authenticate the device and communicate with them securely, and then can dispatch any IoT information to a wide range of destinations. And at the other side of the things, we have where we display the IoT data. Most of the time, if you're in the Microsoft space, we will use Power BI to create dashboard for the business, for the teams. But what do we put between these two components? Most of the time, when developer is going into the IoT world, they want to store data into a classic SQL database, because we, as a developer, we almost all know how to create a SQL database and how to query it and add data in it. The fact is, the operational databases like SQL are not meant to cope with the IoT data. IoT data is generated too much faster and with a higher retention rate, so you may overload your traditional SQL data quite easily. Some people tend or want to use classic data warehouse solutions like SQL Data Warehouse. It's better suited for IoT data, but not the best option, because as you have higher retention rate than other type of data, you might also overwhelm your data warehouse if you start to add any IoT data with a high frequency in it. So to understand why we need to choose big data system and why they are differing from data warehouse or traditional databases, let's see how data warehouse server works. Basically, when you use a product like SQL Data Warehouse, you're installing the SQL database onto one single server with a limited amount of compute, memory, and storage. If at any point in time you reach the limits of this physical or virtual server, you need to grow that server. And we all know that growing a server to a certain extent is A, very costly, and B, has also some limits. So you can go over a certain threshold by using a classic data warehouse solution. The big data systems like Azure Synapse works in a different way. They separate the three main aspects of a database, which is storage, compute, and memory, into different components that can scale independently. First, we have a shared storage. it's in most of the case what we call the data lake. Data lake is an array storage that allows you to store almost an infinite amount of data. Then on top of that, we can add compute nodes. This is where we execute the queries. So anytime you send a query to a big data system, this query got executed on some compute nodes, and all these compute nodes use the shared storage. But when you're sending your query, we need somebody to actually split out the query work onto different compute nodes. This is a control node. So basically, when you're using a web UI as the Synapse web UI we will use in a minute, we are talking to the control node, and then the control node will split out the query to different compute nodes. Each compute node will do its work, send back the data to the control node, and the control node will aggregate the results and send them back to the client. That's why they can scale almost indefinitely, because if we need more power, we just need to add some compute nodes. That's it. So how can we use Azure Synapse to analyze IoT data? As we just saw, in one side of the spectrum, we have Azure IoT Hub, and on the other one, we have Power BI or any other business tool that needs a database to query the IoT data. First, we will create an Azure data lake to store the raw events directly coming from Azure IoT Hub. And then we will use Azure Synapse Analytics to query this data directly from data lake, but also thanks to another component of Azure, which is Azure Stream Analytics, we will store in an organized, in a process fashion, the IoT data within the Azure Synapse Analytics database. By the way, you can also store them in a classic Azure SQL database if you just want to have a wider resolution. So for example, you can output one event per day per device to Azure SQL with the average temperature of this day. It is something you can achieve also with Azure Stream Analytics. So let's get to back to the workshop. I will just need to do a simple thing, and here we are. So if you're following along, your deployment script should be done right now. So as you can see at the end, it will output a few information. I will copy the resource group, and now I will go on the Azure portal to see what the script has created. And again, if you have any questions along the way, feel free to ask them on the right side of the event. So my deployment script has created a bunch of different resources. One of them is a data lake, as you can see. We will explore this data lake later on, but you should have two containers, raw data and Synapse data. Then, quite interesting, it created an IoT hub. And within this IoT hub, if you go here on IoT devices, you should have about 10 devices registered into the IoT hub. One of the cool things IoT hub does is it allows you to directly send events from coming from the IoT devices to some specific destination through message routing. And my script already configured for you two destinations. The one is a default one. We will use it later on with Azure Stream Analytics. And the second one is data lake one. So actually all the messages coming from the IoT devices will be dumped right away into the data lake. And you can also send these events to event hubs, service bus queues, or service bus topics as well. Then we will need some IoT data to actually generate some data so we can process them. For this, I've created a simulator in a form of a Docker container running into Azure container instances. So again, it's all configured for you. The source code for this simulator is not yet public, but it will be in a few days. And you can go on containers and logs, and you should see that some data has been generated for some devices and a number of messages outputted by the simulator. This simulator will run for about 2 hours and then will automatically shut down to protect your subscription. But you can relaunch it if you want to have new generated data. By the way, if you're following along with me, please, at the end of your experiments, delete the whole resource group because we are creating things here that cost a bit of money. So please delete them when you finish. And then, because we need this, it has created a Synapse workspace. So let's go on the second step, which is analyze raw data stored in flat file using SQL. And when you're on the Synapse workspace within the Azure portal, you can actually click here to open the Azure Synapse UI. Synapse has its own UI where you can do all the different steps for actually preparing, ingesting, cleaning, storing, and viewing your data. So it's a all-in-one analytics solution that go way beyond just analyzing some IoT data. So what I want to do first is to explore the raw data I have. So for this, I can go here on the data tab. Here I click on linked, and I will have access to my Azure Data Lake storage. And as you can see, I have here my raw data container. If we look at it, what we saw is we have a folder, which is the name of our IoT hub, and then a hierarchy of folders with partitions, which is a way to scale up the IoT message processing, and then year, month, day, hour, and a bunch of files. And if we look at one of them by right-click and going on preview, what you can see, oh, it's not a great example. Let's take another one, maybe that one. As you can see, there is several JSON documents into this second file. In fact, every line has a different JSON document, and every line represents one message received from an IoT device. So if you have to write a piece of software that browse all these files, and for each of these files, read all this line, and for each of this line, parse a JSON, is actually a complicated task. But with Synapse, you can just go on right-click, new SQL script, and select top 100 rows, and that's it. So if you're doing this along with me, we have created a specific data lake, which is made public and with way more data than this one. So for now, I will follow along on using my public data lake and not the one I created during the setup phase. So here, just to explain you a little bit the query, because it's very easy when you see it. We are using a specific instruction of Synapse, which is OpenRowSet, where I specify where is my file or my files. And here, as you can see, I have some asterisks saying to Synapse, hey, take every file or every subfolder you have in this specific path. Then I'm using CSV. It's a trick to parse a JSON, and that's it. From that, I get a JSON content varchar, which is basically a one column containing all the JSON. So based on that, I can use the JSON value command to actually parse the JSON file. And if I run this query, in a few seconds, the first time it takes a bit more, I will explain why in a minute, I will get a nicely formatted table that comes from all this raw data. As you can see, I have date time, device ID, temperature, etc. And this is what I had in all these different JSON files, all these different lines. But something is quite magic here. It's, as you can see, I'm using here the built-in connection, which in fact is Azure SQL, Azure Synapse serverless offering. So serverless means basically you pay for what you're using, and that's it. And in this case, this means that you're paying just for each query you execute. You don't have to scale a cluster. You don't have to bother about a cluster. You can just execute a query and you will be billed depending on the amount of data your query will read on the disk, and that's it. So if you just have a few queries per month to execute, that's a perfect way to get started in big data in a very cheap way. So you saw the result, but actually how many records I'm looking at. So let's execute the second query where I just do a count, just to see how many records I have in all this data lake. And in a few seconds, you will see that I have a bit less than 1 million records, JSON documents stored into this Azure data lake. So now we have parsed this, we can do interesting queries because this one was quite simple. So I will paste this one to get the average temperature per device. So I will go by executing this query. I will let Synapse read all the different files from all the different devices, aggregate them in a first step by device ID, and then sending out the results. So let's run this query, which is a bit more complicated to execute. But again, we will have a few seconds, like 10-15 seconds. We should have the result of this query. And if you look at it while it's executing, it's, except from this part, the rest is very classic SQL query. Group by, order by, select, that's it. And now we have the results with the highest temperature first. And one of the cool things is we can go here and click on chart and have a chart of all the temperature of all my devices, which is here in this data lake. It represents 1,000 of different devices. It's just not the 10 devices you show. I just show you in the IoT Hub. So I've computed the average temperature of thousands of devices in tenths of seconds. And as you can see, there is a wide difference between the highest temperature and the lowest temperature on all these devices. And if I want, I can export this data. If I just doing an ad hoc query for someone in my team, I can just export them on CSV and use them in Excel if I want. Obviously, you can use also this query directly from Power BI. So here is maybe a business query. For example, let's say all these temperature devices are installed into fridges. I have some problem with some of my fridges, but you can also use Synapse for more technical aspects. For example, this query will tell us how many messages I've received per device. And maybe I will try to see if I have some issue with one of my devices that do not send information as they should. So again, 10 seconds, and I can see that some of my devices are sending a very low amount of messages, like 11, less than 100, etc. And then I have a bunch of devices sending the same number of messages, so I presume these devices are okay. And again, if I look at the chart, I will see there an outlier with one of my devices going crazy and sending a very huge amount of messages compared to the other devices. So by using this, you just pay for the storage on the data lake, and you can execute queries when you want on a ad hoc fashion to see and if you have any technical issues or if you want to assess business things. So that's already, I think, a great product, or at least a great usage. But if you're going to have to do this analysis over and over again, or maybe doing them all day long, or maybe you want to have a dashboard with all this data displayed and updated daily or every hour, this is not the best option. The best option for this is to actually create a system more like a BI, classic BI system, where you create organized tables, and when you pump data into these tables, and you can let data analysts and other people into your organization access this organized data. But for doing so, we will need to create a few more things. The first one, we will need to create an Azure Synapse database. So there is a few things in Synapse. There is a Synapse workspace. When you create a Synapse workspace, it's free, and you get for free the Azure Synapse serverless offering when you pay just per query. And then if you have more advanced analytics needs or more constant analytic needs, then you can create a dedicated SQL pool. So my script is also created a SQL pool for you, and beware, this costs a bit of money. It's the one I've created is I think something like $1 per hour, but it's still some money. So please pause it or delete it if you don't need to at the end of the workshop. And when you're creating a dedicated pool, it acts like a real database. So actually, I can go on my workspace and on tables, and I can create some tables like the tables you have on any SQL database. And in these tables, I can store any information I want. However, these tables will be backed by the data lake. So I get this almost unlimited capacity onto these tables. So for doing so, for creating your tables, you have to execute a bunch of scripts that are listed onto the GitHub repo. And I just wanted to show you a few different important things in these scripts. The first one is, as you can see, a create table order, a SQL statement, which is quite usual. And then we have a specific with clause where we indicate distribution. Distribution help Azure Synapse understand how it should write the data on the data lake. And because I've said replicate here on this one, Azure Synapse will actually replicate all the information contained in this table on all my SQL pool nodes. So it takes a bit of time and a bit of resources, but if you're going to use this table on a lot of queries and a lot of joins, etc., then you get better performance by doing so. Then, as you can see here, I've just hit a select statement on this device table, and I already have some data. I've prepared a script to help you get this data as well. With this copy into statement, which is also a cool one that allows you to load data from CSV, from Parquet file format directly into your Synapse data warehouse. Here you can use as is this script because I've made this file publicly accessible, but obviously maybe you want to load data that need to remain private and not available publicly. You can do so by uncommenting the credential parameter here and by putting a shared access signature for the storage account. Then another cool thing for this copy into statements, here I'm creating the room table, listing all the room in my buildings. Then I'm creating a device table, which is all my IoT devices and where they are installed. So both of them is basically the metadata of my IoT devices. And if you pay attention to this copy into statement, here I am specifying the columns names. Why? Because in this specific CSV file, the column names order, the column orders are not the same than the one declared in the create database statement. So I can mix and match if I want to get the proper ordering by specifying them here. And then on the measurement table, which store any measurements sent by any IoT devices in my system, I will use a different distribution, a hash distribution, to scatter all the information across all my nodes. If you want to learn more about this topic, I've put you some links and also some Microsoft Learn module just in there. So I've already created this in my table, so I can go onto the next stage, which is creating a job that will read the information from the IoT Hub and sending this information out into my Azure Synapse dedicated SQL pool. So I can go back to my Azure portal, and I will add to create a new device. And here I will type stream analytics job. Here we go. So Azure Stream Analytics is a managed solution that allows you to create job to read data from streaming data sources and to send this data out to different outputs. So I will add a job name. I will select the resource group I've just created. For location, I will change it to West Europe. It's not because I'm based in West Europe, but because the script I gave you at the beginning of the workshop actually creates all the resources into the West Europe region. And then I will click here on secure all private data assets needed by my job by using a storage account, and I will select the data lake I've created during the setup phase. On authentication mode for the demo, I will select connection string, and I will go here last thing and select streaming unit to 1. Streaming units is basically compute resources that are allowed for your stream analytics jobs, and you need to scale them depending on the number of events that are processed by your stream analytics jobs, and also the complexity of the transformation you are doing into your stream analytics job. Here, for the simple demo, I can just have one streaming unit. That's okay. And I will click on create. So creating the stream analytics job should take less than 1 minute. It's quite easy. And when we've done this, we've been able to go on the resource and actually create the stream analytics job to configure it. So it's quite easy. You have 3 things to configure. First, the input, which is the source of all the events you want to process. Second, the output, which is where you want to store this information. And then you need to write a transformation query that will read the events from the input and send them to the output. Quite easy. So let's start by the inputs, and I will add a streaming input, and I will select the IoT Hub. I just want to check which is Live EU1 IoT Hub. Okay, so you can just follow along with me here. Input alias IoT Hub. Oh, I already forgot the name. Live EU1 IoT Hub. Live EU1 IoT Hub. Leave this as a default values and click on save. And when you click on save, the input is added and also tested. So you can get any information. If you have done any misconfiguration, you will see it right away. So it's successful. Okay, I can now configure my output. And here I will go on add. And as you can see, you can output things from Stream Analytics to a different range of outputs. For this workshop, I will obviously select Azure Synapse Analytics here. And I will copy paste the output alias, and then I can select my live EU pool. Then I need to explain to Synapse in which table the information will be sent. So here is measurement. Oh, let me copy paste it. It's easier. Then the username. So when I've created the Synapse workspace for you, I've actually created a username and a password on your behalf, which is not secure at all. The username is demo, and the password is this one. And I click on save, and again, the output will be tested, so you can see if you have done any misconfiguration. And last but not least, the transformation query. Oh yes, the table doesn't exist. That's okay for now. So you just have to select something into one of your outputs from one of your inputs. So I've already worked a very easy script, but select fields that are in the measurement table from the Synapse dedicated pool from my IoT Hub. And one of the cool things of Stream Analytics is it allows you to preview the input data, so you know what feed you have ready for use, and also you can test the query and see the shape of the results of this query. So very easy to develop a Stream Analytics query. I click on Save Query, and then you can come here and click on Start to actually start the job form processing. When doing this, it will take a bit of time to get up and running. So you may need to wait like 5-10 minutes before seeing the results. But I've already have a database and a Synapse and a Stream Analytics job up and running, so I can just go to the last step, which is analyzing the data from the measurement table. So I can go back to the Azure Synapse Web UI and on develop, create a new SQL script. And then I will need to do a little extra step, which is here, connect to not the built-in pool, but the other one, the pool I've just created, which is a dedicated one. And then I can query over my tables. So here I have a small amount of data. Let's see if we have any temperature above 6 degrees. Oh, so it seems we have a bunch of data, bunch of different sensors that report temperature over, let's make some space here, over 6 degrees. And for example, we can make a query more complicated with some joins between tables to see which buildings have a temperature above 10 degrees. And it seems that I have a few events here, but all of them are in main building. So I can go check out this building. Nothing very specific to see here, just to give you an idea that if you're creating a Synapse dedicated pool, you can just use SQL to query over it. Obviously, if you're going to have a huge amount of data, there is some tips and tricks to get a better performance. But the cool thing is you can use the tools you know to actually query with data. And that's almost it I had to show you today. So we just saw that you can easily, with Azure IoT Hub, send all the incoming data into an Azure data lake. You can use Azure Synapse Analytics to query the raw data directly stored by IoT Hub within the data lake in a serverless fashion, just paying per queries. Or if you have a huge analytics need, you can use Azure Stream Analytics and Azure Synapse dedicated SQL pools to store this data in a more organized fashion. This architecture schema is a bit more complex, and I'm using a few other products like Time Series Insights, Microsoft Teams, and Logic Apps, because you can do way more than just using Azure Synapse Analytics. So if you want to learn more about this topic, I highly encourage you to go on Microsoft Learn and this specific links, so you can play along on other workshops for analyzing IoT data as well. If you want to see more demo and what you can do with other Azure IoT data services like Time Series Insights, I've made a 45-minute session just around IoT data. I talk about Synapse a bit, but I also talk about other products as well. And with that said, it's all I have today for you. I will just switch to the question. And if you are in a hurry, thanks for watching this fast-paced session. Do not hesitate to follow me on Twitter and on GitHub. And now I will have a look at the question. Thank you, Mark, for your comments. And I will stay a bit to see if you have any any question, because there is a delay between me speaking and you actually hearing me. And again, if you have any question after the session, or if you are watching this recorded, if you have any question, go over to the GitHub for asking any supplemental questions. I will just go back to the slide with the GitHub, so you have it as well.
Christopher, can I say something?
Sure, go ahead.
All right, so first of all, thank you all for joining us, and thank you so much, Christopher, for putting together such a great workshop. I just want to tell everyone, if you're not part of the Reactor community already, please do consider joining us, whether on Meetup or directly on our Microsoft page. You can also check us on Twitter, and you can also check all our previously recorded workshops on our YouTube channel. I just posted the link. And please, everyone, if you have any feedback at all about how this event went, we would love to hear what you have to say. I already sent also the link. Just please use the event code, which is 12471. I just wanted to say that. Thank you so much again. And as Christopher said, we'll be waiting for questions if anyone have.
So it seems we don't have any other questions. So my last word will be, if you have done this workshop with me today, do not forget to go back to your resource group and to go and delete resource, type the resource group name, which is this one, with 2 zeros, and click on delete to ensure that you don't have any costs having this workshop running in the background without using it. Thanks for being here with you, and I wish you a pleasant evening, a pleasant day, depending on time zone.